I'll start again. So today I'm going to make you care about this topic called vegetation-atmosphere interaction. Region 1 is this. So plant takes all the carbon dioxide and converts it into oxygen in the presence of sunlight. And we all know how important is oxygen for us. The second reason, plant also regulates the water cycle as it takes the water from the ground and cools the leaf and then forms the cloud. And the third reason, what plant does basically, it partitions the solar energy into sensible and latent heat flux. As you can see in the left part of the slide, Tom is really sad and tired because there is no plants, so 80% of the solar energy is converted into sensible heat flux. However, on the right side, you see Tina. She's quite happy because 70 to 80% of the solar energy is converted into latent heat. Now you must be wondering, what is this sensible and latent heat? Sensible heat is the heat that we sense or feel. Latent heat is the heat that cools the atmosphere. So basically, we can say that plants are nature's air conditioner. As air conditioner requires electricity for operation, plant requires three things: love, care, and water. Thanks to our kindness, we have abundance of love and care for plants. However, water is not available equally in different parts of the world, due to which you can see different parts of the world have different vegetation types. These vegetation types have also different water requirements. And to understand how this air conditioning capacity of the plant will change with changing climate, so when I say changing climate, it means rise in temperature, change in rainfall patterns. I selected 12 sites from different parts of the world where ecosystem scale measurement is taken. Well, I didn't travel to all these sites. It will be amazing, but I just took these data from, these data are available online. I just used those data. And now I'll explain you all this in a more lyrical way. Energy from the sun, plant needs for all the fun, and the control starts to run. Water and energy exchange begins at the leaf, giving us all life in brief. Forming clouds by taking water from the soil, cooling the leaves down, not to boil. Fun control alternate in range, depending on the climate change. Physical control plays a significant role. Quantifying it is the goal. For us to comprehend, we need to understand. Flux tower measurement is the trend. For us to recommend, we need to understand, not at all pretend. Summarizing literature, focusing on physical control and surface temperature, found inconsistency in formulations and scale, which required data intervention in detail. Estimation of atmospheric control is no more a troll. Let's start to rock and roll. So for my PhD, I have three chords of my rock and roll, aka my PhD. First one was flux tower measurement. Second one was surface temperature estimation. And the third one is plant air conditioning capacity. Well, I worked with flux tower, not flux capacitor, but I'll tell you how cool this is. Flux tower consists of three instruments. First one is radiometer. The second one is eddy covariance measurement system. And the third one is soil heat plate. Radiometer measures the total solar radiation received by the forest surface. Eddy covariance measurements measures the sensible and the latent heat flux. Soil heat plate measures the solar energy going into the soil. In my research, what I found that these three measurements cannot be combined together just by using conservation of energy. Rather, we have to consider the different footprint of the devices. After estimating this, I went to surface temperature estimation. Well, the law for surface temperature estimation was given by Stephen Boltzmann long ago, like in 1800s. So for the gray body, what happens? The original equation for surface temperature estimation had two terms. One component of the second term was not measured widely, and also it was found that the second term has very negligible role to play. This second term was almost eliminated from the equation, and then the equation became just consisted of one term, and this became the trend. When I started my work, I was also using the simplified equation. Then one day, in one of the research paper, I found the original equation. It took me a while to understand which one is right, like the trendy one, which has been used from last 50 years, or the one which was originally proposed. Well, after thinking a bit, I decided to use both the equations, and I estimated the value of surface temperature using both equations for all the 12 sites. And I found that when we use simplified equation, the estimation of surface temperature is higher in the range of 0.5 degrees Celsius to 2.5 degrees Celsius. So basically, the simplified equation is not giving the exact value of surface temperature, and it is wrong to use this simplified equation. But since out of the habit, it was the trend, people were using this. So apart from the scientific understanding that we have to use the complete equation, because these days we have the measurements of the second term available, there is also a lesson of life. Following trend is not always the right thing to do. And after this, I started looking at the physical characteristics of plant which affects the air conditioning capacity of a plant. For this, I found in the literature, researchers have all suggested that the height of the plant plays a very significant role in determining how much cooling capacity a tree has. But in my research, I also found it's not only the height of the plant, but also the size of the leaves. So the smaller the leaves will be, the more recirculation of the air they can do, and the more cooling can happen. So we all know that size matters, but even for the leaf, it matters. So now, just to sum it up, vegetation is used as a carbon sink without thinking about its other link. Under limited groundwater resources, vegetation can still be heat relief sources. Vegetation is a potential solution to the climate change, but its effective implementation needs more research exchange. To beat the heat, vegetation height got all the limelight. Is that all right? What about the leaf size, which we never hypothesize? Leaves clatter, their size matter. Devil is in the detail. Surface to air temperature difference can be the trail. Surface heterogeneity causes temperature ambiguity, due to which climate models lacks clarity. Further research to cohere, we need to consider all the three here: soil, vegetation, and atmosphere. Thank you very much.